Good afternoon, everybody. Today we'll be talking about scrapers. Scrapers are types of equipment that are used to load, hold, and dump loose materials, and actually large amounts of loose materials. Classically or originally, scrapers cannot stand alone as an excavation equipment, but it has to have a dozer to push and load them. However, now the situation has changed. You have the conventional pusher-loaded scrapers, whether single or tandem powered axles, which are loaded by a dozer or a cushion dozer, like what we said when we discussed dozers. However, we also have self-loading scrapers, which are either using the push-pull tandem powered axle technology, or the elevating technology, or the auger technology. And we'll be discussing each on its own. The single power axle scraper, as you could see, this one, the one down there, you could see that it's pushed loaded by a dozer. So this is a dozer loading the scraper. Okay, this part is called the apron. When it's opened, you could start loading or unloading. Here, of course, the process of unloading it's simple. This part called the ejector pushes the soil out while the scraper is moving in order to spread the soil. This is a tandem powered axle scraper, but the concept is the same. Here is an elevating scraper, and the new part here is this elevator. This elevator attachment, it is within the bowel here. As you could see, it could be even clearer here that its job is that it lifts the soil. It has something like a conveyor belt here that lifts the soil from down to the back of the scraper in order to accelerate the process of filling this bowl. The auger scraper, this is an auger scraper, a photo of an auger scraper. This is a section in the auger scraper. As you can see, this is an auger, very similar to the continuous flight auger that's used in piling. However, it is short, so it's simply excavating beneath it and then dumping the soil within the bowl itself using this screw. So this is even faster than the elevator. So simply the loading steps for if you follow this shape from A, B, C, D, E, A is you're loading, then you are approaching the cut, then you are making the cut, then you are the apron. Of course, the apron should be open during loading. Of course, it's moving this way, and the ejector is at the back. The ejector is to the rear. Then you finish the cut and you lift the bowl. You raise the bowl and close the apron. This part is called the apron. Okay. Of course, you will travel while the apron is closed. You will move, and the apron should be closed always. The bowl should be raised for the travel. After achieving your location, you start positioning your bowl at the correct location, and then you will start opening the apron. Okay, and you will move in that direction while the ejector is moving forward. So you move backward, the scraper will move backward while the ejector is moving forward in order to push the soil out. So in such a case, if we look at the volume, this is what we call the heaped volume. And the shaded part is what we call the struck volume. So the struck volume is simply the volume without this heaped part, the volume of the bowl without this heaped part. Why are we discussing that? Because when you read any catalog for any manufacturer catalog for any piece of equipment, you'll find this terminology. You'll find there is a struck capacity and a heaped capacity, a struck volume and a heaped volume. So this difference, the difference between them will be this heap. As you could see, in case of having an elevator, this elevator occupies a large part of your volume. So this is the problem of having an elevator, also having an auger within your scraper is that you're having something that will occupy a large volume within your bowel. However, for sure the process will be faster. The cycle time will be less. So what will affect our productivity? If you look at these 10 factors, you will understand that 10 of them are related to the three powers that we were talking about before: the available power, the required power, and the usable power. So the rolling and grade resistances, the class of material, type of tires, they are all related to the required power, coefficient of traction, the job and management conditions, physical conditions. They are all related to the usable power, and the remaining are related to the available power. So again, the concept of having a productivity, you need to have your capacity, the volumetric capacity in the numerator. You will multiply it by whatever factors of efficiency and job conditions. Then you have the cycle time in the denominator. And again, the cycle time, like any piece of equipment, you have a fixed component and a variable component. The fixed component is typically spotting, loading, maneuvering, and dumping. So these are samples for the fixed components of cycle time. However, you will notice that these times will change depending on the type of the scraper itself. Okay, and of course depending on the conditions of the job. Also, the variable cycle time is mainly a function of hauling and returning times and hauling and returning speeds, which is a function of the amount of soil that you are carrying. So if the job is lighter, you are faster. So if you are carrying a lighter load, you will be faster, the speed will be higher, the hauling time will be less. Returning, you are returning empty anyways, it doesn't make a big difference. And again, both are function of the grade resistance, or the effective grade plus rolling resistance percentage. So that takes us to these types of charts. We have two types of charts. The first is the classical ones that we discussed before 2 lectures ago, when you have what you call the performance charts that you could get the speed of the equipment from. However, here you could have somebody did a little bit part of your homework for you. He gave you two charts, one for the loaded chart, and one for the empty case. So he'll give you a piece of equipment. He'll tell you why this thing is 100% loaded. So he'll give you the vehicle empty weight is blah blah blah. The payload is blah blah blah. So this plus that, this is the total full load. Okay, and this is your effective grade depending on these curves, depending on these lines. This is the distance you will get. So if you know that your distance is maybe 1,000 meters, so I'm here. It's 4% grade, so this is the 4%. So this is a 2.1 maybe minutes. Okay. So this is if I'm moving 4% on such a case. Suppose that for the same 4%, I'm looking for the empty weight. For the empty weight, for sure, the 1,000 versus the 4% will give me less time because it's empty. So it's 1.5 seconds, 1.5 minutes. So again, for sure, the empty time will be less than the full time, especially if we're talking about the same grade. But of course, the grade will change because maybe you are the wiser thing is to move loaded while downhill and move empty while uphill. Of course, in some cases, circumstances force you to do something different than that. So let's take a nice example here. We'll estimate the production for the wheel tractor scraper given the job information below. Use the travel time curve methods in figures 5.1 and 5.2. The scraper type is a single engine overhung. The loading method is single pusher. The material is sandy clay. These are the unit weights of the material, and please be aware of this issue that here you have two unit weights, the banked unit weight and the loose unit weight, which is of course the banked unit weight is heavier. So in this case it's about 1900 kilogram per bank cubic meter, and 1519 kilogram per loose cubic meter. So we'll go to the rolling resistance. We'll find that it's 100 pound per ton or 50 kilogram per metric ton. So this is 100 over 20. This will give us 5%. The scraper capacity, the rated payload is 32.7 tons, while the heat capacity is 23.7 loose cubic meters. You must be very aware that these capacities are based on a certain calculation for a certain unit weight of a certain soil. So you need to check it when doing your job. The altitude rating factor is 4%. This is something very special for this case. It's not a general thing. If we didn't mention this issue, take it as nothing, as 0. The job efficiency factor is 0.83, which means it's 50 minutes per hour. The hauling route, section 1, it's leveling a road, you level loading area. Section 2, you move down a 4% grade for 610 meters. Section 3, you level dumping area. Section 4, you move up a 4% grade, again the same 610 meters. Section 5, you turn around for 183. So let's first calculate the load per cycle. So the weight of the heat capacity, actually it is the 23.7 loose cubic meter, the volumetric capacity, times the 1519 unit weight. So this will give us 36,000 kilograms. So the weight, actually, in such a case, you need to be aware that this thing, it will exceed the maximum rated payload, which is 32.7 kilograms, 32.7 tons. So in such a case, you need to calculate the ratio between what? You need to calculate the new load. You need to calculate the new load, whether in banked units or loose units, depending on the case here. So here we'll calculate it in banked units. So the new load in banked units will be the maximum payload, the 32.7 or the 32,659 kilograms, divided by the 1,899 kilogram per bank cubic meter. So this will give us 17.2 bank cubic meter per load. Okay. So now things has changed. The load is less because my material itself is heavier. The effective grade is 100 over 20 or 550 over 10 minus 4. So this is 1%. While returning, it is now the plus, the minus became a plus. So now it's 4 plus 5, not 4 minus 5. So this is sorry, it's 4 plus 5, not 5 minus 4. So this is a 9%. The turnaround is, because it's a level grade, so this is a 5%. So when we get the travel time from the curves, we find that section 2, it's 1 minute. Section 4 is 1.6 minutes. Section 5 is 0.45 minutes. And you must be very aware that section 4 and section 5 are from a different figure than section 2 because the weight is different. Okay? In section 2 you were hauling, so this was full. Section 4 and section 5, it's empty. So you will use figure 5.2, not figure 5.1. Of course, then you will adjust for the altitude. So you will add the three numbers and multiply them by 1.04. This is a 3.2 minutes. You will not always need that. We have this only for this case. Okay? But if you didn't mention it, don't use it. The fixed cycle time is simply loading, maneuvering, and spotting time. These sum up to 1.6 minutes. So the total cycle time is 1.6 plus 3.2. This is 4.8 minutes. So the estimated production is simply the 22.5 times 60 over 4.8 times 0.83, 233 bank cubic yards per hour, and in metric units, it's 17.2 times 60 over 4.8 times 0.83, so this is 178 bank cubic meter per hour.